Hi everyone, welcome to the regression analysis lecture. This is one of the subjects in the Statistical Science Study Program, Department of Mathematics, University of Indonesia. So for this session, we will be discussing in more detail um, model building for quantitative variables and more specifically on just one predictor variable. Okay, so we have this template of the model beta naught plus beta 1 x1, but the aim of this session is that we will try to examine what really a function of x1 that is suitable to be put in this model. Okay, so we just go straight to our simulation. So here I already, um, produce some codings to generate the model for our purpose. So I generate like 100 of a sample size of 100, and then with with many variations on the functional form of y. And then so basically in model building, especially when you have just one predictor variable, to decide on what functional form is suitable to put in the model, a really uh, efficient and straightforward way to do it is that by doing data visualization. So that's what we are going to do now. Okay, so let's say we have this kind of relationship between x and y. Okay, so we have that this is x is the explanatory variable and y is the response variable. If you get this kind of trend here, so what function do you think that's suitable to represent the relationship between these two variables? This is just a straight line, right? Okay, so in this case, I will propose some model, okay, just like this one. Okay, so I will propose that my model is just expected of y equals to beta naught plus beta 1 x1. Okay, and of course with the expectation that since since this graph is as x increases, then y is also increasing, so I will expect that the beta 1, the sign of the beta 1 should be positive. Okay, so this one is kind of like something that you are very familiar with. Okay, now let's look at other pattern. Okay, so if we have this kind of visualization, again, I will just still propose this kind of model, just beta naught plus beta 1 x1, no transformation at all for the x1, because this is also just kind of like, a straight line here. Okay, and then since x increases, y decreases, it means like negative correlation. So I will expect that the beta 1 here, the sign will be negative for this if we have this kind of a relationship between those variables. Okay, so what if we have something like this? Okay, so, sorry, still the same. What if we have something like this? Okay, so if you have this kind of graph, okay, if you want to put in like, straight line, yeah, it's okay, but I think this is just really good for this part of the data, while for this part is not really fitting. So here we can see kind of like, early the data kind of like x increases and then y a little, uh, increasing as well. And then at some point there's an inflection point. So when x increases, y no longer increases yet. Instead, it's just starting to decrease. So there's like a bending point here, one inflection point. You can see this is a curvature trend. So then for here, I will propose my model is that not this one, but then I will choose beta 1 plus x1 here plus beta 2 x1 squared. Okay, so this is what we called a second order model. Okay, and then here from this kind of relationship, okay, you know that you can expect that I think that what is it, the beta 1 here, not beta 1, the beta 2, we will expect the value of beta 2 should be like negative, right? um yeah, because it's like downward curvature here. Okay, if you're confused why is it negative for the coefficient of this one, just open again your calculus book on the chapter of functions. Okay, so now what if we have a different pattern, something like this. Okay, so actually similar with the previous one. Okay, we have that this is kind of like also a curvature trend. So in here I will propose again still with the same model, just the same like this, but the difference is only because this is an upward curvature, so I will expect that the sign of beta 2 is positive. Okay, so we can just put the same what is it, the previous one. Okay, and then and then just to do our comparison, and then okay, so actually from here you can see having just one explanatory variable here. So we have, if we have this kind of pattern, it's really clear that it is just a first order model. So in here just beta naught plus beta 1, where beta 1 is positive, here beta 1 is negative. For this kind of graph, like a curvature, one bending point or one inflection point, then we will propose a second order model. You add the quadratic term. Okay, and then we will expect that, okay, for this kind of pattern, downward, we will expect that the beta 1, the coefficient for the quadratic term should be like a negative, and for this one it should be like positive if I'm not mistaken. Okay, so now what about, let's say, let's have a look at different pattern. Okay, I just make it bigger. Okay, let's have a look at different pattern here. Okay, if you have something like this, if we try to add like, what is it, straight line. Okay, let's just try to put a straight line. What is it here? Okay, y5. Y, oh, oopsie, that's wrong. Okay, so if we think that we want to put a straight line here, then you can see that lots of data points are not close, not even close to the line. Okay, so just a straight line model or the first order model like what we have here. Okay, the first order model here, that's not really good to represent this kind of relationship. And then as we can see before, we have one inflection point. You order the curvature, you propose a curvature, the quadratic model. In here we can see, okay, a little bit increase, and then after some points start to decrease, and then at some point start to increase again. Okay, so we can say kind of like there is one and 2 around here, 2 inflection points, and then again refer to your calculus or your math functions, what is it, lesson, For curvature or curvature trend with two inflection points, it means that we need to propose a third order model. So for that kind of pattern, I will put here that a third order model. So x1 cube here beta 3 um, x3. Okay, so that's our third order model. Okay, that's for this kind of what is it pattern. But again, this is kind of like, okay, mathematically speaking, we put something like this, but then later you also need to consider the complexity of your model and the sample size that you have, whether you really need to put all that higher order model, or you need to like make it a more in a more simpler model. Okay, so now let's have a look at the pattern here. So if you have something like this, what do you think the relationship between your explanatory here and the response here? Okay, if you can see here, okay, again, if you put like what is it, a straight line, okay, so if you put like a straight line here, and then see, it doesn't really fit the data, okay. Lots of the points are not even close to the line, so we need to do something, okay. If you think like it's a quadratic, so probably you can propose a quadratic model, okay, like this is an upward curvature. But then now we will try something different. I think that I will just try the this is kind of like an inverse function, okay. So 1 on x, y equals 1 on x, something like that. Okay, so here for this one, actually you can try to propose this model, okay, kind of like, you know, half quadratic form here. But then we can also try something else, that is, in this case, I will try, instead of x1, I will do 1 over x1. Okay, so that should be, what is it, my proposal for this model. Okay, 1 over x1. So this is called the, what, let's see. So beta 1, 1 over, let's see. Okay, so just beta 1, 1 over x1. Okay, so this is called an inverse function. So inverse function. Okay, um, the pros for this model compared to using the second order is that this is much simpler. I mean, in here you only need to estimate two parameters for the coefficient regression, while in here you need to do estimation of three. Remember, more parameters to be estimated. The payoff is that you actually need to have more data. Okay, so the model is much simpler, although we also need to do some kind of transformation, but the same with here also. You can't really just work on just x, you also need to have like the quadratic form. Okay, so that's for this pattern. Let's try another pattern. Okay, something like this. Okay, so in here probably what kind of function that properly represent this thing. Again, if you try to force the linear, you know, just the first order, then you can see that it's not really fitting the data. Okay, so that's if we try to put like y here, y7 equals beta naught plus beta 1 x2. Here we simplify with x2, then we see that lots of data points are not even close to the fitted line. Okay, so that first order model is not recommended for this one. And then, so if you look at the curvature here, if you want to put like x squared, okay, so it means that the trend is going up, like like this, while in here is on the reflection. So probably you might want to put in the model is that instead of x squared, but this is like a different way. I mean that in okay. So here, the model that I will be proposing is that the square root of x1. So this is another transformation that seemingly kind of like can represent this kind of relationship. Or if you know your logarithm functions, you can also see that this is kind of like also resembles a logarithmic function. So then here you can just try as an alternative to propose like the form of beta naught plus beta 1 and not the square root, but then the logarithm of x1. Okay, so you can try to propose these two models for if you see this kind of pattern. Okay, so that's some examples of relationship between x and y, and then how you address the relationship, how you put like an appropriate functional forms in the model. Okay, so here we have that the template for the first order model, or sorry, for just a simple regression is just this one. This is the template, the one that we have here. Okay, I just highlight it. Okay, so that's the template actually. But we know that x1 there, x1 here, can be changed by anything. That anything is decided by functional form, the mathematical form of a relationship between x and y. Okay, and to be able to do that, okay, you need to do your data visualization, and then you really need to know the behavior of different types of functions like quadratic, cube function, logarithm function, square root function, and something like that. Okay, so that's all about model building for one predictor variable. Thank you.